All right, so my name is Robert Chichon. I am an associate professor in the Department of Forestry and Environmental Resources at NC State, where I study forest health, specifically forest insects. I've spent most of my career to this point on hemlock woolly adelgid and the impacts it's having in the southern Appalachian Mountains and beyond. But just in the last few years, I've begun to get involved and become a little more focused on some of the issues that Christmas tree growers are dealing with insect pests in their fields. So we have two projects currently going on in our program. One is focused on balsam woolly adelgid and selecting genotypes with increased tolerance or resistance to that pest. And that was a project I started with Dr. Frampton before he retired, and we're finishing it up now as he has already gone off and enjoying his post-work life. And the other project is one I just got involved in the last year or so with Jill, working on the elongate hemlock scale issue, which I think we all know has become an important regulatory issue for Christmas tree growers in the state and affecting our ability to continue to sell our trees into some markets. So I talked a little bit about this project at the winter meeting back in February. But just to give you a quick reminder, we're coming at this question from a lot of different angles. One of the questions we're trying to answer is how long after you harvest a Christmas tree is the scale really a problem? So is the cutting a tree, packing it on a truck and moving it across the country, are the scales still viable and producing viable eggs and crawlers? And is that a viable pathway for introducing the pest? We're also doing some work to better characterize the phenology of the scale across the growing region and its relationship with its natural enemies and what natural enemies may be existing in the fields that we could perhaps be taking advantage of in our management. We're also trying to learn and evaluate a good sampling scheme in fields so that we can go in and survey different growers' fields for scale and understand the different patterns of scale infestation and how that might relate to their management practices of in those fields, but also to other characteristics like proximity to forest edges, where hemlocks in the surrounding forest may be contributing to the scale infestations. And then we also are interested in some other projects where we're going to look at the potential for commercially available biological control agents for release and control of scale in certain situations where that might be suitable. And of course, with my continued interest in applying forest genetics to tree health and forest health issues, we are also going to explore some opportunities for seeing if there may be some naturally occurring resistance to scale in some of the breeding material that has been developed through the Christmas tree genetics program at NC State. So we hope to work in collaboration with Dr. Justin Whitehill, our new Christmas tree geneticist, who's just joined our faculty. So I'm, along with Jill, the project leader at NC State for this research, and we're very excited to have Dominic Manz, who has just started this past May in the middle of the pandemic as a PhD student working on this project. And so Dominic's already started working a little bit despite the restrictions of the pandemic. And so Dominic, why don't you share with everyone a little bit about what you hope to work on the next few years while you're part of the program?
Yes. Hey, everyone. My name is Dominic Manz. I am a graduate student from Switzerland. I've done my undergraduate at State and proceeded to do my graduate work as well. We are hoping to work on three things mainly from what Robert has already told us about. We're trying to find a suitable sampling scheme to do a field survey that Robert already did explain briefly. So we've already done 1 week of data collection in the mountains where we practiced one sampling method, and upon reviewing it with the other members of the committee, we decided to practice or try another method soon where we try a binomial approach where we hope to gather a lot more data points with the same number of trees. So we would get a better idea of the distribution within a field. We would get an idea of the distribution among the tree. We already have an idea about that, you know, crawlers settling on the lower crown, but we would need some empirical data for that as well. And the severity within the field, not just the distribution, but also the severity. So we can compare it with grower management practices when we look at the survey, as well as information from borders, adjacent fields, and adjacent forests, as Robert has suggested before. All right, so the second objective is the post-harvest trials to see how viable and how long they potentially could be viable. Crawlers could be after the tree has been cut, like Robert has suggested in the introduction. When a tree is cut and moved from one place to another, how long could the tree could potentially produce viable crawlers and enhance spreading of the insect over time. So there has already been some experiments done on this last year by Robert, and the preliminary data on that suggests that they can be up to 70 days they can produce viable crawlers. Now, in my project, we're trying to figure out under different storage conditions how different storage conditions would impact that number. How long can a tree that has been stored in a cooler at ambient temperature, or in other ways, influence that time? Would it just prolong the time, or would it be shortened? Also, we were trying to figure out, are these populations viable enough to infest seedlings, or are they just producing surviving specimens? The third objective we're trying to look into is the phenology of elongated hemlock scale in the Fraser fir natural range, as well as potentially the phenology of natural enemies, predators, parasitoids. For that, we're trying to look at 3 farms. Currently, we're looking at 3 farms in the northern part of the range and 3 farms, I think, in the southern part of the range. That's what we agreed on. And we're trying to figure out if how weather, climate, aspect, topography impacts the life cycle, how it impacts the rate of development, and in the same question, we're also trying to figure out if there are synchronies between known potential enemies, or if there are known potential enemies that we could synchronize the life cycle with.
I'm standing in a field in the Fleetwood area of Ashe County, and this is one of the fields that we took Dominic Manz to do his preliminary work, looking at a more intensive scouting for elongate hemlock scale. And of course, in this instance, we were looking at every 3rd row and every 3rd tree in every 3rd row. So that would be 1/9 of the trees. We would look all the way around the tree, all 4 sides, brushing up the foliage, and then the rating scale that we were using went from 1 to 4, with 0 being no scale, 1 just a detect with a few needles on 1 shoot, 2 being more than just a detect but less than 10% of the foliage with scale, 3 being between 10 and 50%, and then 4 would be more than 50%. The reason why we chose this field is because Brad Edwards and I had sort of a history here. We've been scouting here for a couple of years, and the reason why is because the grower has been treating this field with horticultural oil in the late winter to try to control the balsam twig aphid eggs before they hatch, and also to knock back issues with scale. And the reason why is because there's a beekeeper close to here, and so there's been some issues because of that. So we knew that there was a little bit of scale in here, but not a lot. And so we wanted to know how easy or hard it was to detect that, how many trees you had to look at. So as a grower, most growers are probably looking here and think there's hardly any scale at all. When we did that more intensive scouting, again looking at 1/9 of the trees, what we found was over 50% of the trees had at least a detect. Most of that scale was back into the canopy of the tree, and most of it didn't look very active. So the grower had been doing a good job of controlling the scale. Again, he'd been treating here every year. But even that rating of a 2 on a tree, if once that tree is cut and baled and that foliage is brought up, if that's someplace where an inspector could find it, it could be an issue. I'm standing at the other end of the field where Jerry and I are doing our long-term elongate hemlock scale study, looking at treating with Savanto in the spring and Safari in the summer. This is the second year we've done this. And then we also took Dominic Manz here to do his more intensive scale study. And this portion of the field is where we were working, and then compared to the larger trees over there, which the grower is managing. And so if you look at these trees, 75% of them have elongate hemlock scale on them. 43% have more than a detect, so a rating of 2 or more. Of course, a rating of 2 would have less than 10% on one side, but that still can be problematic. And then 14% had a rating of 3 or more. There was definitely more scale on this side of the field next to the larger trees, as well as this end of the field, because across the way there used to be a lot of bigger trees that have been cut out and removed now. Here's a photograph of a small tree showing mottling and the white from the male scale. Now, I did quite a bit of scouting in here last year, doing a zigzag pattern, and I was able to pick up with that pattern the fact that there was more scale on this side, and got about the same level of infestation. So that is a good way to scout, and again, we're going to be trying to work out the best way to scout for scale so that you really know how much scale are in your trees. Jerry's going to be treating these trees again shortly. We're now at the end of August, so those applications are going to be a little bit late with Safari, but we'll see how well they work. So this is another field where we did the intensive scouting for elongate hemlock scale, where we sampled a 1/9 of the trees, every 3rd row and every 3rd tree, brushing up the foliage and looking all the way around the tree, giving it a rating of 0 to 4, which I've spoken about before. This particular farm had the most scale in it. 99% of the trees had elongate hemlock scale. 58% had a rating of 2 or more, so more than just the detective scale on those trees. And 22%, almost a quarter, had a rating of 3 or more. So at least 10% of the foliage had scale on one side of the trees. When we did the same sort of rating in the block where we treated with Safari last year, again we found that 99% of the trees had elongate hemlock scale, but in that instance we only found ratings of 1, which is just the detect, or 2, which is up to 10% of the foliage. We did not find any more than 10% of the foliage with elongate hemlock scale. So it appears that our Safari is working, and we'll be applying treatments again this year, and we'll be following it up again for next year.